B and point C. These 3 points is just projected on the plane surface. In real world, here is point A, maybe the top of one here, and this is point B, this is point C. We say point A, X, Y, H is given. We know that. So B and C, we don't know. So we want to survey it. How to do that? So we say for 2-dimension location, that means X, Y, we can survey angle and distance. Angle and distance. For example, if we wanted to get the X, Y coordinate of point B, we can use the total station to survey the horizontal angle of alpha, and then use the total station or EDM, electronic distance measurement, to survey the distance between A and B. So we can use alpha and distance to calculate the coordinate of point B. And this coordinate is just projected on the plane surface. Yeah, plane surface is just located the horizontal position. So for the 3rd dimension, the elevation of point B, we can use level instrument to survey from point A to point B along the line on the ground surface. From point A to point B, survey the elevation difference between A and B. So if we have the elevation difference, so here A is elevation, H is known. So H plus HAB, so we can get the elevation of point B. So we use total station survey angle and distance to locate the horizontal position of point B. That means we can get the X and Y of point B. We use a level instrument to survey elevation difference between A and B. So we can locate the 3rd vertical dimension of point B. So we say elevation difference, and here angle, and here distance. These 3 elements is the most important things in survey. Okay? Okay. This we say the 3 elements. And the history of survey, I think this is not very important. You can read the book yourself. Yeah? But generally, we say in the last decades. So the history is just always say the development. We can draw a conclusion. The instrument of survey is just from object to electrical, and the method is from handwork to automatic, and for production, the paper to digital. Yeah. Okay. I think this is can be understand. Okay. This is chapter 1. So next, we will know chapter 2. Leveling. We say, if we want to determine the location of points, we have 3 elements to survey, and the elevation difference. First, determine survey by some special instrument and some special method. This is chapter 2, leveling. After this class, we will do experiment first. So we say next week, Monday, 10 o'clock, 10 o'clock, go to engineering building 2, engineering building 2. Yeah, B513, B153.
Monday or Tuesday? Monday or Tuesday?
Monday. Next Monday. However, okay. Engineering building 2. Okay. B513. Okay. So we say the monitor should take the list and you should be divided in 3 groups, and each group you should have a leader, yeah, have a leader. And then go here, I will wait in this office, and we will take the instrument and then take outside and do the experiment. Okay, this is our first experiment. The first experiment is very easy. It's just to know how to use of the lab instrument. Okay. Okay, this chapter we will know the definition and the principle of leveling and the elements of surveyor level, type of the instrument used, and the method of leveling. And here we have 2 supplementary. One is the 3rd and the 4th class leveling in China. That means in our book we just talk about some normal method in leveling. That means in that situation we just can get a elevation of points in not very high, not good process, cannot get the elevation of point process. But for engineering points, for engineering project, we say the first principle is we must establish the control framework, yeah, control framework first. So if you want to do control survey, we must use 3rd or 4th class leveling. Okay. And then accuracy in leveling and mistakes in leveling and some suggestions. Okay. First, elevation survey. If you want to do survey for elevation, that means we want to determine the elevation of points. To determine the elevation of points, we have many methods. First is leveling elevation survey used with high precision. So this method, leveling, is most popular method in engineering project. Use this method, we can get a precise elevation of points. And so we say this is the main method. And then trigonometric elevation survey. Sometimes this method is also used in engineering project, especially in engineering project of bridge above the water, above the ocean. Like that great project, sometimes we we have to use this method because we have no condition to take leveling on the surface of water. Yeah. Okay. So we must use this method. But if you want to use this method, be carefully. It's very easy to cause error in observation and result. And the 3rd, air pressure. Of course, here sometimes, especially in flights of plane. And the other is GNSS elevation survey. That means we can use the GNSS method. What is GNSS? Maybe in different countries we call this system different line. For example, many years ago we called this as GPS. I think this all of you can understand the GPS. Yeah? GPS. What is GPS? Global position system. Yeah? This system is created by American. Yeah? By American, and especially in military. Okay? And if you launch a missile, so this system cannot miss. If you without this system, the missile will blind and cannot touch the target. Yeah? Cannot attack the target. Especially, this system is used for some military purpose. So different country have different idea. So Russia, so they create another system as GLONASS. GLONASS is also a satellite system to used for military purpose. Yeah, these two can just create roughly about at the same time, but this system created firstly by Soviet. So they have no money. So many satellites is broken, missing. So this system is broken, cannot work well. And nowadays, the Russia and launched massive satellite and use them and make this system work again. And the third is Galileo. It's created by Europe. But this system just cover a small area. And China and India and invest many money into this system. But many years ago, they give not enough power to China. So China developed another system. That means Datum. Yeah, Datum. Its English name first named as compass. So, and here, this and this and this. These three systems now is covered global all around the world. Okay, this is the three main satellite system for navigation. So, because many years ago, just this system can work, so we say we just use this GPS as the name of this kind of system. But nowadays, because we have this three systems, so we use another name, GNSS, as the name of this kind of satellite system. That means Global Navigation Satellite System. Yeah, that means this. Because many years ago, just this system can work, so we use this name as this kind. Okay.
Global navigation.
What?
Global system.
This global navigation satellite system. Maybe in your country, maybe the name is different. Yeah. Okay. Use this method, you can survey the elevation, and you, of course, both horizontal and vertical position can surveyed by this system. But usually, the horizontal coordinates can be got precisely, but the elevation position can be got roughly. Its precise is lower than this and this method. Okay, but the most important thing for this system is you can get the data very quickly. Okay, just 1 second, you can get the coordinate of any point on the ground all around the world. Yeah. So, if we can't resolve this system, so most missile, most weapon can lose the power, especially in about 10 years ago, 20 years ago, a war between America and Iraq. So they turn off the GPS system in how to say that? That means American can use this system, can attack the target, but in the area, in the country of Iraq, any weapon cannot use this function to locate to locate the target. Yeah. Okay. Just at that time, the Europe, Japanese, and China, and India, and Russia began to develop the system themselves. Okay. That also means the coordinate points is very important for a country. For each country, the coordinate of points is secret. If you survey and even in practical training, and if I give you a coordinate of this point in our country's system, you survey it and get the result. That means this result is also secret. So in practical training, I just give you assumed coordinates. Okay, in any country, is that. Okay, first definition and the principles of leveling. We say in this picture. Leveling, the procedure for determining the difference in elevation between apart points. That means here, this line is ground surface. This is ground surface. We have 2 points on ground. One is point A and one is point B. So from point A to point B, we do survey. Do what survey? Do leveling. Then we can get the elevation difference between these 2 points. And here we use elevation difference, then we can determine the elevation of a point. Why? Because, for example, here this curved line means the level. That means the geoid surface. So we say here the elevation is 0. Yeah, 0. For a country, so if we do leveling from here, the original elevation point of the country, survey what? Survey leveling from here to point A. So we can determine the elevation difference between A and O. So here we can get the elevation of point A. If we do leveling again from point A to point B, now the elevation of point A is known. So here elevation of point A plus elevation difference between point A and B. So we can determine the elevation of point B. Yeah. So you can imagine in China or other countries in this great area, if we want to determine the any points elevation. So this is a very, very hard work. Yeah. Very, very hard work. So if you do leveling, you must from here to here just walk step by step. Yeah. Okay. So you need many people to do this, and even more than 10 years first to establish the control framework. And the data, that means the standard surface, that means the 0 surface, usually is the geoid. So we also can call the mean sea level. Of course, I said just now, we say in a engineering project, if you want to use relative elevation system, so the data, the standard surface, the 0 surface, you cannot use geoid, yeah? Okay, but for a country, this usually is geoid. Okay, but another point you must say, for different country, the position of geoid is different. Even in China, in different years, we say the first year of establishment of People's Republic of China, so the geoid might be, the position of geoid is different for now, because many years have passed. The date of observation of the position of geoid is changed. Yeah. Why? Yeah. Firstly, for example, the year of establishment of new Republic of China is 1949. Yeah. In that year, we have no money, no people, no technique, no engineer to take observation. So the channel is so big, so big. So for example, this is Yangtze River. In Chinese is Changjiang. Yeah, this is Huanghe River. For example, and here is in Guangdong province is Zhujiang. For example, here is Beijing and here is Tianjin. So, so like this. Okay, it's not very nice, but like this. Okay, this is Beijing. So, because the area is so big for different part, different province, they cannot take leveling observation all around the country. So that means we cannot establish the control framework for this whole country. So in this area, in Guangdong province, they just do observation at what position? At this position, the Zhujiang River, and this is the sea, and in this point. Yeah, and they stand there and observe the position of the sea surface, and then get a mean position as the position of the geoid as the zero, So here, this area, they survey the elevation from this point, and for this several provinces, we use the Shanghai because the Changjiang Yangtze River just here to into the ocean, and use this as the zero. But this 0 point and this 0 point is not equal. It's not equal. So in this situation, for whole country, if we wanted to build a railway from Beijing to Guangzhou, and we are through different system, different elevation system, so you cannot finish this engineer. Yeah. So many years passed. So we have money, we have enough engineer to do the survey. So we just used Shandong province here, like this, Qingdao city, and here just use this point to determine the position of geoid, and then get a result as the original elevation point of whole country, and then from this point, and then establish the elevation control framework from whole country. It's even from here to Tibet, okay, even to survey the elevation of Zhongnan Peak, yeah, all from this point. In this situation, the whole country elevation is just used one system. Okay, this may be in 1950s, and then after 20 years roughly, then we establish and get another more precise elevation position of geoid, and then use that to refresh all data again. Okay, just use today. Okay. Okay, the classification in China, the leveling will be classified in 4 classes, or we can say 4 order. 1, 2, 3, 4. That means 1 order. The first order or first class is more precisely than second, and then third, and then fourth. Yeah, and this is 5/5. The fifth, that means is the normal class leveling, is just to use lay out the point in engineering. But first, second, third, and fourth can use to establish the elevation control network for an engineering project. I must say, this is just in China. So, in any engineering project, you must obey this some certain specification. Yeah, the specification is very, very important, because the specification is the law of engineering. If you didn't obey that, so that means Yeah, the result is not worth believe. Yeah, okay. So maybe in your country, the class is not like this. It's not like this. So if you want to do control survey or other precisely survey for leveling, you must find out your own specification. Understand that?
Yes.
Okay. In the subject in course, we just use the specification of China. Okay. Okay. Here is the leveling, some best definition, and this is the tail in some certain specification. You want in municipal survey specification. Of course, there are many specifications in China about survey. For example, here is municipal survey. We have other just specification for leveling and some for geodetical survey and for GNSS survey and for tunnel survey, for bridge survey, for road survey, for railway survey. Yeah, and in this specification, maybe the limits. For example, this limits number maybe have some like different each other. Okay, so we say even in one country, if you do leveling in bridge project or other people do leveling in road project, maybe the specification there should be a bit is different. It's different. Okay, that means the limits, this number limits is different. Maybe. Okay, and this limits index. No, here in the class we will not talk about that, but in experiment, in practical training, I will tell you detail. Okay, this, and here in this picture we say here we have another conception. Here is vertical line. Vertical line is blank line, gravity line. We say last class we call this as the reference line in field work. Yeah, in field work. That means this line is the reference line of the field work of the instrument operation. Okay. So second is level surface. The surface of wood at rest. We say at one position, for this one point, we have innumerable level surface. Yeah, just only one is geoid. Yeah,
How can
geoid.
you measure the surface of water at least?
How what?
I mean, because if the river is flowing,
Flow.
How can you measure the surface of water at least?
And understand. You mean slab surface?
Yeah, the surface is not
Ah.
at least.
Level surface, you have many, yeah? Have many level surface, innumerable. But this is not important. We just only one, geoid, means sea level is the standard surface. Yeah, okay. Why we mentioned the level surface here? That means just any level surface we can use as the reference surface of the operation of instruments. Any. We can use any of that as the reference surface of the operation for instruments. The third is level line. Like this, you also have many, yeah, innumerable. Any level line, we can use the reference line for the operation of instruments. And another is the horizontal line. Horizontal line is a straight line perpendicular to the vertical line.